Melissa, thank you so much for joining me. This is a conversation that I feel is like long overdue because you have been with this company from before it was Writer, I believe. Is that correct?
That's correct. It's been 6 years at this point. And when I joined, we had like 30 people, and the company was called Cordova. So after Spanish City. So yes, totally different times. Right now, we have more than 400 already employees, right? So it's like more than 10x growth.
The trajectory has been exponential in the past, I would say, year or so. But let's back up because I didn't even give you a chance to introduce yourself. So, can you tell us who you are and what you do?
So I'm Melissa. I'm a research scientist that writes research. My background is in mathematics, physics, and sinology, Chinese language. My story of machine learning starts, I think, 10 years ago, but that wasn't a professional experience. It was discovering AI by my own. And then professionally from 2017, which makes it like 8 years. So I tried to 6 years. So that's my experience. I mean, that's the company that captivated me very, very long. So still excited about, what's coming. You can never predict what's going to happen in writer. So that's, I think, the best part. So that's why 6 years, because it's never get boring.
It keeps you guessing, it keeps you,
Hmm.
it's never boring. Never a boring day.
That's true.
So, I want to back up because you said you discovered AI on your own. I want to hear that story. What was happening in your life? What was that moment for you?
Oh, everything starts in China. Uh, so I graduated from sinology, Chinese language, and I got 1 year scholarship. And I ended up in Chengdu in China. It's like a city in the center, in Sichuan province, like seeing spicy food, tea. So this is the place, amazing place. So after the scholarship ended, after 1 year, I switched into being a teacher. So I was teaching IT and math at high school. And I had a hobby. Like, this is the time when I discovered programming. So I started from ActionScript and Flash because that was how can I facilitate my students to learn faster, to learn better, to memorize better. And then quickly it became JavaScript and trying, things on my own, like you see students learning. So the question is, can I create an algorithm that learns? Of course, at this point, you have no notion of AI, right? You never came across machine learning, this phrase. And yeah, how do you learn? How do you create a learning algorithm? So after years, I think I realized what I was writing that time was k-means and supervised clustering. So the task was like a given handwritten signs, like it can be a heart, it can be any sign that you want. Several classes. Can you write an algorithm that learns to classify those patterns for you? So I think right now I think that was cute, right? I would write in like maybe like 4 lines of code right now, but that time it was very very challenging. So no fancy phrases, this whole craze that we have right now about AI. Just discovering things on my own. So yeah, so this is when it all started.
So, I've noticed that a lot of the stories about the first encounter with AI is usually in the context of, well, AI in some form existed in the software where I was using or as a recommendation engine or something like that. But when I talk with people like you, like people Wasim and Umar, it was language. Language is what brought you to AI. And I think that
Hmm.
is such a cool pattern of this thread that brings us. And I actually want to ask you, so you started just studying Chinese. What brought you to that to begin with?
Chinese. I mean, doing a bachelor in sinology. I mean, it all started with physics because I always wanted to be a physicist. But then I discovered that what excites me the most in physics is actually mathematics. This, the theoretical part. So I then transitioned to mathematics, but mathematics is it's purely abstract. So while studying mathematics, I discovered that part of my brain is actually not working. I mean, I know this is already not true because people proven that you have this left and right, like division, like of hemisphere in your brain, and the one is responsible for logical thinking, and the other is creative one. So I know this is no longer true, right? This division, but anyway, I was discovering that a part of me is not developing. So I just, chose something maximally different from mathematics, and that was Chinese. I need to admit that Chinese because it's challenging, right? It's completely different system, like everything from phonetic system in Polish, like leave this aside and adventure into the wild. So you don't have an alphabet, right? So completely out of your comfort zone. Even if you learn like history of China, like China was isolated from Western countries for a very long time, so it's going to be totally different, right? You have no expectations pre studying Chinese history. Also, like syntax in Chinese is different. Like you have no future tense, right? So how do you deal with it, right? How do you start thinking in different categories than you got used to? So that's why I wanted to experience something completely new. So mathematics and Chinese, and I like what I enjoyed the most is switching between departments, because the same day you could have a Chinese class and then a math class. So like completely different. I love the feeling of switching between those departments. So that's why Chinese.
When you say that a part of your brain wasn't working with math, is that dyscalculia? Is that what you're saying? Is there a learning disability that you had?
No, it was related to like in mathematics. I have a feeling like there is this thing like you can spend 10 hours on thinking about a math problem and have no results, right? Like just to give you one thing that is different between those two. Like in you can go to Chinese and you can spend those 10 hours learning Chinese sounds, right? So you're going to see the progress, right? Like so the progress depends. I mean,
Okay, so it was about fulfillment.
yes, yes. So complete different style of learning, different skills that you need to pick up for every major. So this is what made it the most exciting. Like it was, I felt like it was complementary. Like when I was at Chinese department, I liked mathematics, and then on mathematics department, I always fantasized about going back to Chinese department. So that's why it felt complete for me.
And it feels like there's something like a natural inclination then that led you to machine learning and AI, since that's ultimately what you're bringing together is mathematics and language.
Hmm.
I mean, is that where you're at right now? Like you're where you're supposed to be?
That's a difficult question. I would say the Chinese adventure for me was mostly it was known that after studies we will get a scholarship to China. And again, like a journey to a country that you maybe okay, you learned right during your studies something about China, but then like what are you going to do there? As a mathematician in China, like what kind of job you can get there, right? So that was very amazing because it's like progressing into the vagueness. I know you have maybe you have this experience like the greatest idea come from vagueness, from when you don't know what to do, or even if when you're bored, right? Outside of your comfort zone. So that was for me a time to think like what I want to do next. And it turned out that machine learning is what I actually want to do next, right? So even without the labor that time. And I remember meeting amazing people because every person that you meet, an expert in China, they have a story, right? So every single story was something that you would not see normally in your own country. I mean, like you, of course, there are interesting people in your own country as well, but like me, the density of those stories is much greater. So people giving me ideas. So I've told you about K-means clustering as the first idea, but then came something else also related to machine learning. So I found out that actually, as a mathematician, I found a lot of common with linguists. So I had a team of linguists. Yes, language again. I mean, like, this is what I discovered, right? So I needed that journey to discover that.
Mm.
So a team of linguists, and we are thinking about how to design piece of software that would do like memory enhancement. Maybe you have this problem like when you wake up in the morning and you have this blank page, right? Like you're asking questions like what I wanted to do today, right? Even before the first coffee, right? So like blank page, right? What I wanted to achieve today. Who am I? Also, Like you're browsing the internet, right? And you see lots of things, but you remember only a few, right? And I wanted to have a piece of software that would track my internet activity and tell me something about myself. And of course, if you try to do that, you naturally come into into machine learning. This is exactly machine learning, because you see text, right? Text is simple. I mean, like relatively simple, but you also see pictures, right? So how do you represent pictures? Right now, of course, like after those years, in machine learning, I would say like it's all about embeddings, right? You just need to learn good embeddings. So you need to have a good encoder model. But that time that was before reading everything in machine learning. So we actually spent a lot of time trying to design those features ourselves, those embeddings, and trying, come up, with the first system. That was also a great info. Also, how do you, like later, if you go back to the system and you want to understand something about yourself, it cannot be fragmented, right? It should come in some clusters, like some concepts. For example, a few articles that you saw recently. So, of course, clustering, right? So this is another big part of the machine learning, right? Supervised clustering, unsupervised clustering. So we were coming up with those ideas because we needed them. We needed, to understand ourselves better, right? That was the main objective. So machine learning was like a tool that came up naturally, like you check Wikipedia page, you have, a term, and then you discover that actually this, there is a broader field of study behind this, and this is only one piece.
Yeah, that was what I wanted to know is you're doing this discovery here, and in the meanwhile there's this whole world of machine learning that exists that you don't know really exists. Is that really what's happening
Mm-hmm.
there? Oh my
Yes,
gosh.
yes.
So when you discovered machine learning existed over here, what was it like for you?
I mean, this is what I need. This is exactly what I need, right? So you come up with one, algorithm like k-means, and then you discover actually there are some other alternatives, right? They are different. Like you can do DB scan for clustering, and they have different properties. So you start applying those algorithms. Of course, like you come up with the algorithm that is not perfect, and then you discover that actually people are working already more than 100 years on this problem, and there are improvements to this. So it's like you upgrade. So that was amazing.
Do you remember that moment that you realized, oh, this entire discipline exists over here? Do you remember what brought you to that discovery?
I think at that moment, not yet. Uh, I think that was my first data science project, my first data science job that really pushed me into discovery. Like, because what I'm describing right now is like, like a group of friends thinking how to embed a picture so you can find it later, right? Like you might think like retrieval augmented generation right now that we offer. So this is kind of what we were trying to achieve. So like a brainstorming session, like let's go to a bar, let's grab beer and think about how to embed pictures, how to embed text, right? Because we are talking about times before transformers. So I think that time you might find LSTM if you looked for, right? If you didn't know, then you still need to go, to classical linguistics, how to describe a text, how to feature engineer text. So at that point, not yet.
And it feels like this moment we're talking about is very much that magic of the beginner's mindset, right? So because you're not acculturated to this entire discipline, you're coming at solving these problems in a way that maybe these seasoned machine learning experts wouldn't have approached it because they learned it a certain way.
Exactly. Actually, this is a piece of advice that I give to interns or people that join Writer. Is before you start working on a topic, think about how you would frame it yourself, because once you start reading papers, you will converge to how they frame this problem, and it's very difficult to escape from that box once you're in the box. So think about it yourself. Even establish like the success criteria, right? For you, what does it mean, for example, that the model is performing well on a task, right? For you, yes. So I think this is a great approach. Of course, you need to have some foundations like mathematics and so on, but then going to a specific use case. First, think yourself about the problem, and then check where other people converge. That stage was mostly like exploration stage before converging. Right now, I'm trying to achieve the same before starting a new topic, but it's difficult, right? Because when you think about solving a problem, the first thing that comes to your mind is an LLM, right? So the exercise, imagine there is no LLM right now, is harder, of course, and you would be surprised like how many problems can be solved without LLMs.
Well, I mean, we happened to have existed for millennia without our
Hmm.
LLMs. We've had these LLMs. Uh,
Exactly.
so I want to move forward in time a little bit with you. So you joined the team then Cordoba. It might have not even been Cordoba then, but I'd love to hear the story about how you fell in with the writer founding team.
So yeah, so as I said, 30 people, and I remember when I joined, we had 2 people or 3 people in the NLP team. Right now, we have several teams doing NLP. At that time, it was just one team. And I remember my first task was training a model for grammar. And that was very challenging because when I joined, we had a system, a rule-based system, that delivered those grammar suggestions. It was not obvious whether an LLM can actually do the job well. So it's like, first of all, it was like proving it is possible. Then, they were squeezing every single bit from the LLM, given less resources that we have right now. Right now, we have a big cluster, right? We can use a big LLM. That time, I remember I considered T5 a large model.
Talk to me about what that means because I don't know what a T5 is.
Just to give you the scale, right now we are talking about models in the scale of billion parameters, and that model was less than 1 billion parameters. That's the scale I'm talking about, and that was encoder decoder model. Right now we are using decoder only models, so I mean the technology already shifted a little bit. But I remember T5. Oh, that was huge, right? That was the newest piece of software, let's say, in machine learning. So everyone was excited. So I was excited. I was excited too. So when T5 came out, we all jumped in. What's interesting about Writer is nobody told me how to do that. They told me, you will find a way. Just take your time, look around, you will find a way. Also, excellent thing about this place is constraints. The usual approach to creating such systems is you have a data. In Writer, what we emphasize, we don't use customer data. So how do I develop a system without data? And at first you can be angry, right? Because oh no, this is unfair. I don't have the data. I can't, create a solution. And then you think about this. Oh, this is an excellent constraint. So let's solve the data problem first. So actually, the first model that we created was to generate the data. So we trained a model to generate the data. And I think that was an amazing idea because that was like, I would never come up with this if not given those constraints. So that was my very first project. It took 6 months. So that was a long project, but I never felt pressure that it should be done in this way, not the other way. So that was amazing. Okay, now you will put this in production, right? So usually people have this limited experience, like you just create models, right? You have benchmarks, you prove that the numbers are right. And then that's the end of the story. You hand it over to MLOps team, right? Or engineering team, and they deploy the model to production. If you have 30 people, then it's you responsible for doing all of this. So for me, that was an excellent experience of putting my stuff in production because research and making things run in production, those are completely different notions, right? Because in production, they told me you have 3 seconds. No, there was 300 milliseconds per one sentence, per one segment. Right. So all of those techniques that, try to optimize for the performance, like test time, techniques, all those tricks, they simply don't apply, right? Because my user writes and they want suggestions like as they write, right? Because I won't be going back to what I wrote after 10 minutes, right? I want to correct this on the fly. So how do I make it into 300 milliseconds, right? So you need to go for various optimization techniques. Right now, the standard answer is GPU, go for GPU. But then, like, how do you monitor GPU, right? It turns out that it's much simpler to use CPU, right? So what kind of techniques can you use in order to take the model to CPU? So that was a real adventure, honestly. And then babysitting the service, making sure it does not explode. Of course, it exploded, of course. I mean, that was part of the charm, of learning things. But that was amazing. Right now, I see that we tend to specialize, right? Because we grow. I think I still have this privilege that some of my solutions are in production, so I'm asked, to maintain them. Please go and fix something. So I still somewhere in between production and research, which I think this is priceless experience.
Wasim has talked about one of the things that really differentiates our approach to model development and release is the fact that we, and I'm going to use the wrong terminology here, Melissa, but ultimately this is about not just resting our laurels on benchmarks. We only test production ready models, right? So before like the quantization stuff,
Hmm.
do you feel like perhaps the nature of your work, the fact that you were in research and then had to put it in production, that you kind of got rid of that standard or industry standard for writer? Where did that approach come from?
What is very special about writer is, like everyone in the industry is relying on benchmarks. That's true. But the benchmark is like a cherry-picked use case. Of course, like the hope is like if you produce enough benchmarks, right? Like let's say thousands, right? They will tell you something about the model. But the truth is like there is one piece that is missing in all of that testing, and it's very time consuming because it's going to a human being, asking the human being, could you please use that model in production and tell me what's the vibe? Do you like actually talking to the model, right? Do you notice something that, for example, it's perfectly fine in benchmark, but for example, annoys you, right? Like the general feeling about the model. So we always say that the vibes test is the most important. I mean, like after you satisfy all of those benchmarks, you go and do the vibes check. Quantization is fine. Distillation is fine as long as the model that you offer to the client is the final one. Because what is very annoying is that, for example, I start liking a model, right? I rely on the model in my when I work, and then one day I see a completely different version because it's all about prompting. It's not like those prompts are universal. There's no such thing like a model agnostic system. So every system needs to take into account the model specifics, like because every model is different, right? That's why we do this extensive testing, because we want to know the characteristic of the model, how to design a system on top of the model. So if you, for example, have a startup, right, and you rely on API, and then suddenly, the API provider changes the model, your entire business is in pieces, right? Because everything that you created so far on top of it, it stops existing, right? You need to have an army of, people of QA trying to fix those things again. So I would say keeping things stable so people can rely on your API, rely on your product is the most important thing. So the clear versioning of models. So as I said, quantization is fine. It's like squeezing a bigger model into smaller GPU. So this is fine, but make sure that whatever you deliver is final.
A lot of times I see all over Reddit, ChatGPT is not working as good as it when it first came out and things like that. That's the story behind that.
Yes.
Is this distillation and quantization where they were like, ah, here you go, public. And then, oh, wow, this is taking a lot of GPUs. Let's squeeze it into a smaller model. Yeah.
Hmm.
Mystery solved, right? What are some of the exciting bits of research that you have moved on from? You moved on from grammar checking to now, I mean, we are full scale platform, end to end platform with agents and these very, very sophisticated models. So that's a huge graduation. What does that feel like for you? And where is your curiosity taking you?
Our biggest bet right now is agents, right? But everybody thinks about agents like in a different way that we are thinking about agents. That's my impression because what the context that we hear about agents usually is the context of like ChatGPT, right? Like for individual users. When you think about agents for enterprise, the story is completely different. Maybe you could have two separate terms for those two concepts, like agent for enterprise and agent for individual customer. For me, the most exciting part is I've been seeing a lot of stuff, being published in the literature. How does it translate, or if this translates to enterprise? The answer usually is no, it does not. For me, like if you have greenfield, right? If you notice that something is not defined, this is like, yes, finally, I can contribute something to the field. So this is the most exciting part, like defining what an agent for enterprise really is. And I've been thinking about agent for enterprise like an automation. So it's not the agent that every time asks me for permission, right? Can I, for example, save a file in your file system, right? Can I, for example, open the browser? Can I use your credentials? I wouldn't like to use those agents. I know for safety reasons, this is what people are implementing. But if you take this kind of agent to enterprise, that's probably not the best idea for automation because the idea of automation is I don't do those clicks, right? So how do you make things safe, right? But how do you go from managing one agent that constantly asks you something on the screen, right, to thousands of agents that you can manage, like security wise, because security is our highest priority. So, how do you manage like a group of agents, like thousands of them? How do you measure the output of thousands of agents instead of one agent, right? That you actually scroll, you see the output of, and you can actually validate case by case. So, this is, I think, the biggest challenge and the biggest difference between those two approaches, like the self-evolving models. I think that this is something that comes naturally when you think about agents. Because if I have a workflow, it means that I want to use this workflow several times, right? I mean, several, maybe thousands, right? It's not that I want the agent, to complete the task once and then I move to something different. I mean, me as Melisa, right? This is my use case. But for enterprise, it's you keep using the same agents with similar workflows, like clusters of workflows. So it feels natural to learn from those workflows, right? As people invoke them. So self-evolving concept is, can we make agents learn as users use them, right? Can we make them better and better on the same workflows? Yeah, so this is very exciting concept. And again, I remember our CTO, Wasim, introducing self-evolving idea. And that was, I think, before everyone else was thinking about it. And then right now you have self-evolving architectures everywhere, right? And I opened those papers, and again, the conclusion is no, that's not suitable for production. No, that's not for enterprise. No, that's not.
Mhm.
That's something different because we gave people some constraint, right? Find out something that you could call self-evolving. And the approach that people have is like recently we have Alpha Evolve, right? The DeepMind solution. And I see that what they evolve is actually the database, right? So like you might think that this is a system, right? That has several pieces. One of this is LLM or maybe two LLMs. Do you have a database and so on, like a memory? And the question is which part people try to evolve. So in their case, this is a database, right? So I don't think we would like to have an LLM playing with a customer database, right? So it's like, okay, nice idea, but next, there are companies that try to embed evolvement in the architecture itself, like Transformers Squared, Titans. All of them have disadvantages and advantages. We have our own proposal for self-evolvement that both touches the memory and the LLM itself. So exciting piece of research. I think the most demanding we had so far, and I hope to see that in production. I think that's the most exciting part, that we will use it.
From what I understand, and please correct me if I'm wildly off target here, is that our research into self evolving models is really focusing on how can the model just learn as it goes as opposed to having to revert back to a training mode to learn.
Yes.
Correct? Okay.
Mm-hmm.
And from what you're telling me, DeepMind is saying, well, you do that when you move the customer data around in such a way that it evolves. Or in the other case, it was like just embedded in the architecture itself, and ours is kind of slightly outside of the model, as well as the model is designed to be receptive to that type of learning.
I think more or less. I mean, the biggest difference between our solution and this, as I mentioned, Alpha Evolve, is that Alpha Evolve is designed for code, and in a situation when you have verifiers. And if I want to write an email, sorry for the very simple use case, but if I write an email, I mean, there is no verifier saying like this is a good email, this is a bad email, right? So you don't have this check that you have in code. So I would say, like in their case, also the use case is different. What they do is like combinatorial search, right? So you have an algorithm, you have a quick check, and you try constantly, to rewrite the program for a certain algorithm, like for example, matrix multiplication, right? And then check whether you are doing better, collecting insights, and so on. So in our use case, we work with unstructured data. It's rather text, not code. We don't have verifiers. It will be so much simpler, to work with code. But we have constraints, right? So which makes our task more challenging, but also more exciting, I think.
More innovative.
So that's the beauty, yes, of a writer.
When you're in the weeds of this world, first of all, are you a casual user of AI in your world outside of work?
I mean, of course.
Okay.
So honestly, I don't think I can imagine my day without AI right now.
Me neither.
Yeah, so yeah, all in the same boat, right? They are very down to earth use cases, right? For example, like summarize a research paper, right? Because I want to digest five research papers today instead of one. That's very straightforward. Or for example, write an email, right? I'm not a native speaker, so having, at least a proofreader for me, that's an excellent use case. But again, down to earth. So the question is, what can you do more with LLMs? And I do have lots of experiments going on, honestly.
Are these like tinkering, just Melissa being curious type of things?
As always, yes. I mean, sky is the limit, right? I think with even with the current technology, we can go very, very far. So it's only about the imagination. Like what I like to do is, I have my personal notes. Like when I work, I write some notes. Like generally through the day, like maybe a list of tasks and so on, like unstructured texts, like single, plain text file. And what I like to do is like first thing that I already mentioned, like I wake up in the morning and I asked the question like, "Who am I?" Based on my notes. You can be wrong. It doesn't matter, right? So 9 of 10 cases you will be wrong, but this one case you will tell me something I don't know about myself. So what I was planning today, like, can you tell me like what task I did not complete this week, so I could do them today? So that's very very standard. But what you can do more is based on my notes. Can you tell me, am I happy? Right? Guess based on artifacts that I produce, what do you think about me? Like, or maybe suggest something that I could do better, right? Of course, again, this assumption is that artifacts that you produce are representative of your state, of your personality, and so on, which is not always true. But this is like a fun game to play with an LLM, right? I mean, I did have an even wilder idea that's sort of been validated today when I saw the news. So let me first tell you the idea and then the news that I saw today. So going back to the idea, my second project with linguists. So imagine that you collect all artifacts that you see, right? All of pictures, like even sound, everything that you can collect, even conversation with other human beings. Of course, if they agree. So this is your input, right, as a human being. And then try to train an LLM on this input and try to ask the LLM, what's my next action? What's my decision in a specific situation? Like there is this conversation whether people have free will, right? I know that like lots of approaches and it's an open topic. Like if you read Sapolsky, determined, you will hear the very famous like there is no free will, right? But usually how it's framed is you have free will if your next action is not fully determined by your history, like the entire input that you get. So I would love to train an LM on the entire input. And then I would love to check to what extent I'm random, to what extent it can predict what I want to do next. So it's like an exercise, like,
And
am
then
I
you can
free?
make a
Do I have free?
breakthrough. You can consciously be like, well, no, I'm going to do this instead. But then the LLM informing you of that is part of your history. It's
That's
a
true.
paradox.
So it's it is, but like fun exercise, like checking, do I have free will? Of course, there are plenty of assumptions that might not be true, but I think it's a nice exercise. And the news that I saw today was, I think there was Telegraph reporting that there were negotiations, like governments negotiating, and somebody created an LLM that would mimic a person. So before going to negotiations, you would first talk to LLM in order to practice, the negotiations
Mm.
with that person,
So
with that modeled
role-playing
person.
diplomacy, basically, yeah?
Yes, yes. When I saw this, like,
Oh,
this is my
that is
idea.
yeah.
So ideas can be really wild. It depends on your assumptions, because every time, of course, you need to assume something, right? Like my artifacts tell something about me, or for example, like the free will hypothesis, right? The next token, the next action prediction. Like I know there are people trying to memorize family members by training LLMs. And again, like, what's the assumption here? The assumption is like that everything, that entire reality is in your brain, right? That everything happens just in your brain. The reality does not exist. It's just your imagination. So the other person is then the actually what happens in your brain when you talk to them, right? So that's the assumption. So that's why training on conversation with somebody, and then interacting with an LLM, like with this person, if it gives you the same reaction, right? This is actually this person, right? If everything is a projection of the brain, right? So again, assumption not necessarily true, because I think that you are there, right, on the other side, not just my imagination, but by making different assumptions, you can really have fun with LLMs. So definitely the sky is the limit. I don't think we exhausted possibilities of LLM. Even if we don't advance in LLMs and we freeze where we are right now, still so many applications to come up with, even with this technology.
Is there other advice you would give your past self?
Actually, when I think about this now, like, when you do Knox token prediction, right? Those tokens that happened before are very important for the current token. If you change anything in past tokens, you will diverge from the trajectory that you're at right now. So there is a possibility that you would not end up getting the token that you have right now. So an LLM analogy. So I've been thinking about my token right now, and I'm really happy where I am. So I would not give myself any advice, because I'm really happy about the trajectory so far.
I love that answer. I love it. Thank you so much, Melissa. This has been an amazing conversation.
Thank you for inviting me. Have a nice day.